ટેન્શન ઘણી વાર હું ચાલુ લેક્ચર કરી દઉં છું, મને ખ્યાલ નથી આવતો. ઓકે ઓકે, all of you clear this first two example?
Yes, sir.
Okay, so write down next example, third example. Write this: a resistance wire of 10 meter length, 10 meter long, and cross section area 10 millimeter square at 0 degrees Celsius, a current of 10 ampere when connected to a DC supply of 200 volt. Calculate the resistivity of the material, and second, calculate the current which will flow through the wire when temperature rise to a 50 degree. Temperature rise to a 50 degree. All of you first write down the given data. શું આપ્યું છે પહેલા લખી દો. So length is given, L is equal to 10 meter. Then cross sectional area is given 10 millimeter square. So convert into meter square first. So it is 10 into 10 raised to minus 6 meter square. Then current is given at 0 degrees Celsius. So it means initial current is given, which is I0 is equal to 10 ampere. Then voltage is given, V is equal to 200 volt. And here alpha 0 is also given, temperature coefficient 0.0003 per degree Celsius. So first you calculate resistivity of the material, second calculate current which will flow through the wire when temperature rise to 50 degrees Celsius. Alpha 0 is given, temperature coefficient at 0 degrees is given. So give me the answer of resistivity.
2 into 10 raised to minus 5.
minus 5.
Yes, very good. 2 into 10 raised to minus 5. What is the unit of resistivity?
Ohm meter.
Ohm meter.
Yes, ohm into meter. Yes, very good. All of you please calculate this. I give you some time to calculate this first. Those who have calculated the first values, calculate the second value. Current flow through the wire when temperature rise to a 50 degrees Celsius.
Sir, do we have to convert this Celsius into Kelvin?
Yeah, there is no requirement here.
Okay.
So I explained you the first answer, how to get this resistivity. So we have all this data. I'll have area I0 we have 10 ampere, voltage we have 200 volt. So as we know the equation of resistance, that is rho L by A. So you can see that resistivity equation becomes R0 into A divided by L. Yeah, so resistance is given.
Sir, current will be 9.85 ampere? Okay, sorry.
Yes, you already get this. All of you get the first answer, 20 into 10 raised to minus 6. First you find out the resistance R0. How to find out? First you have to calculate the value of current. First calculate the value of R0. So voltage and current both are given. Voltage is 200 volt, current is 10 ampere. So R0 is what? V by I. So V is, here it is a 200, not is 100. 200 volt is given. Okay, so 200 divided by 10. So you get the 20 ohm resistance. So as you know the equation, R0 is equal to rho L by A. So R0 you have 20, L you have 10 meter, area is 10 into 10 raised to minus 6 meter square. So from this equation you get the answer 20 into 10 raised to minus 6, or you can say that 2 into 10 raised to minus 5 ohm into meter. Clear? So this is the answer of first question. Second question is that current which will flow through the wire when the temperature rises to a 50 degrees Celsius. So as we know the initial resistance, so as you know the equation RT is equal to R0 1 plus alpha 0 into T1. RT is nothing but value of resistance at any temperature T. Here we want to find out the resistance at temperature of 50 degrees Celsius. So that becomes R50 is equal to initial value of resistance, that is 20. We already calculated here, into 1 plus alpha 0. Alpha 0 is given in the example 0.0003, and into T1. It means temperature. So it is 50 degrees Celsius where we want to calculate this. So the final answer of this is 20.30. But we want to calculate the current. So current is what? Voltage divided by resistance. So voltage is 200 and resistance at 50 degrees 20.30. So answer is 9.85 ampere. All of you get this answer?
Yes, sir.
Yes, sir.
कोई डाउट
Yes,
है
sir.
एग्जांपल में?
No, sir. No, sir.
Okay. So can we move for the next example? बधाने कैसे calculate?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So next example, fourth example, write down this. A copper coil has a resistance of 12.2 ohm at 20 degree, 28 degrees Celsius and 14.8 ohm at 44 degrees Celsius. Find temperature coefficient of resistance at 0 degrees Celsius. Second, find out resistance of coil at 0 degrees Celsius. Third, calculate temperature coefficient of resistance at 60 degrees Celsius. And fourth, resistance of coil at 75 degrees Celsius. So I give you 5 minutes to calculate this example. So all of you take your time and give the answer of all these 4 answers.
Sir.
Yes, bolo.
Sir, 0.137.
0.137. No.
Sir, 0.016.
Yes. Answer is 0.016. What is a unit? What is a unit of
Degree Celsius.
temperature? Yes.
Celsius inverse.
Yes, Celsius inverse. Yes. All of you please calculate first alpha 0 temperature coefficient of resistance at 0 degrees Celsius. Those who have calculated, please calculate second, third and fourth.
0.448.
What is the value? Second answer?
Yeah, 0.448.
No. Resistance of coil at 0 degree Celsius?
Yeah.
No.
Sir, 8.43.
Yes. 8.425 ohm. Second answer is 8.425 ohm. So I explain you first two questions, how to get this answer of first two questions. So first we find out temperature coefficient of resistance at 0 degree Celsius. So what is the given data here? The resistance is given R1 12.2 ohm at 20 degree, 28 degree Celsius. So that is T1. Then second resistance R2 14.4 ohm, that is given at temperature 44 degree Celsius. So you have equation of R2 and R1. So as you know the equation, RT is equal to R0 into 1 plus alpha 0 T. So if you combine both this value, so and take the ratio of both this equation, so the equation becomes R2 divided by R1 is equal to, here R0 is cancelled out. So equation becomes 1 plus alpha 0 T2 divided by 1 plus alpha 0 T1. R2 is what? 14.2 ohm. R1 is 12.2 ohm. Alpha 0 we need to calculate. T2 is given 44 degree, T1 is given 28 degree Celsius. So if you simplify this one, so you get the alpha 0 that is equal to 0.016 Celsius inverse. Celsius inverse, that is the unit of temperature coefficient. All of you get this? Is there any doubt?
Sir,
Yes?
we can keep the first resistance as the reference resistance. I mean, the resistance is reference temperature.
Yes? I don't understand what you want to say.
I mean, we can't do that. R2 is equal to R1 into 1 plus alpha delta T. Then in place of R1, we can keep 12.2.
Yes, you can take any ratio. You can take R2 by R1, also R1 by R2.
No,
You get same
no,
answer.
sir. I'm saying that R2 is equal to R1 into 1 plus alpha delta T. Then in that we can't keep R2 is equal to 14.4 and R1 is equal to 12.2.
See, what is the value of R2? 12.4. At which temperature? So that is temperature at 44 degrees Celsius. Here,
Yes.
sorry, it is a T2. Okay, it is not T1. It is T2. What is R1? 12.2 ohm. At which
Yes.
degree? So 28 degrees Celsius.
Yes.
Okay. So as we know the equation, RT is equal to what? R0 into 1 plus alpha 0 into T. Okay.
Yes.
So you can make the two equation, R1 is equal to R0 into 1 plus alpha 0 T1. And same way second equation.
Yes.
So you can take the ratio like this way.
But okay, we can take the ratio, but in place of R0, we can't take 12.2 and direct solve it with one equation.
Yes, you can solve by any equation. Okay.
But then the answer for the coefficient is different. 0.13.
No, you get the same answer. You get the same answer. Calculate by other way.
Just a minute.
Calculate again.
Excuse me, sir. Hello.
Yes, bolo.
Sir, is R2 14.2 or 14.4?
Sir.
Sorry, it is 14.4. Yes, it is my mistake here. It is 14.4.
Okay, sir.
So, sir, we can do with one equation, no?
Yes, you can do by any equation. Yes.
Sir, can you display the question again, sir? We are trying the next ones.
What?
Sir, can we try third and fourth now?
Yes. You all understand the first question? Or if you get this answer?
Yes, sir.
Okay. So second question is what? Resistance of coil at 0 degree Celsius. It means you need to calculate R0. So as we know equation RT is equal to what? R0 into 1 plus alpha 0 T1. R0 is unknown quantity that we need to calculate. So R0 is what? RT divided by 1 plus alpha 0 into T1. So RT is what? You can take any value of the resistance. 14.2 or 12.2. Okay. So if you take this, suppose 12.2 ohm resistance, which is at a degree of 28 degrees Celsius. So T1 becomes 28. Temperature coefficient we already calculated 0.016. So You get the answer 8.425 R0. Temperature, resistance at 0 degrees Celsius. All of you get the second answer?
Yes, sir.
Okay, second answer badana mali gyo chhe?
Yes, sir. Yes, sir.
Yes, sir.
Okay. And third is we need to calculate temperature coefficient of resistance at 60 degrees Celsius. It means alpha 60. We need to calculate alpha 60. So there is a one equation, the relationship between alpha t and alpha 0. So suppose initial temperature coefficient is given alpha 0. So you can find out the temperature coefficient alpha t at any degree by this equation, alpha 0 divided by 1 plus alpha 0 into t. So alpha 0 we already calculate 0.016. T is 60 degree at which we want to calculate this alpha. So finally you get the answer 0.0082 Celsius inverse. All of you understand this? You remember this equation. There is a relation between the temperature coefficient at 0 degree and at any temperature T degree. So you can calculate the temperature coefficient at any temperatures. Suppose you need to calculate 7 degree temperature coefficient. So just put here T is equal to 70 here. Clear all of you?
Yes, sir.
Okay, next move for the fourth, resistance of coil at 75 degrees Celsius. Again same equation. RT is equal to R0 1 plus alpha 0 T. So R0 we already calculate in this second question 8.425. 1 plus alpha 0 we calculated in first question into 75. 75 is the temperature at which we want to calculate resistance. So answer is 18.54 ohm. Clear all of you?
Yes, sir.
Is there any doubt in this 4 question? Yes?
No, sir.
No, sir.
Okay. So I move for the next question.
So
Right down.
can we just copy the question once, the last one? This
Okay,
one.
okay, write down. Okay, all of you please write down this example. Okay. All of you please write down all this example in your notebooks. Okay. So it is easy for you to refer this example during the exam. Exam વખતે તમે recorded video જોવા નહીં બેસો. Okay. So it is better to you to write down this example in your notebook. બધા example લખવાના છે. Okay.
Sir, what will be the syllabus for the first exam, sir?
First internal exam, your syllabus is first 3 chapter. First 3 chapter of your syllabus.
And sir, when would that be?
It is, I think, maybe in the second week of December. I think academic calendar is given to all of you. બધાને આપ્યું નથી academic calendar?
Yes, sir. It's on 14th December.
હા તો આપી દીધું એમાં લખ્યું છે 14 લખ્યું છે ને. ઓકે ઓકે.
Yes, sir.
કેલેન્ડરમાં તમારે જોઈ લેવાનું ક્યારે ફર્સ્ટ ઇન્ટરનલ છે, સેકન્ડ ક્યારે ફાઇનલ એક્ઝામ છે. આખા વર્ષનું ટાઈમ ટેબલ તમને આપી દીધેલું છે ઓલરેડી. બરાબર છે? Clear this, all of you?
Sir,
Both are?
please repeat the question.
Okay, so fifth question. A 100 watt, 200 volt bulb is connected in series with a 100 watt, 25 volt bulb across 250 watt supply. So here there are 2 bulbs is given, both are 100 watt but different voltage rating. One bulb is of 200 watt, another bulb is of 250 watt. Both are connected in series, and across these 2 bulbs, voltage applied is 250 volt supply. So first you calculate circuit current, and second is voltage across each leg. Here assumption is given that assume the bulb resistance is remain unchanged. So why this assumption is given? Because as the temperature will change, your resistance will also change. So to make this resistance unchanged, here this assumption is given. There is no value, there is no change in the value of resistance. As the current will flow, we know that temperature of the wire will increase. So that may affect the value of resistance of this bulb. But here we assume that there is no change in the value of resistance in any condition. So for this condition, you calculate these two values, circuit current and voltage across each lamp.
Four point one. 4.1.
Circuit current. First, find out circuit current. You need to find out I.
Circuit current is equal to 4.1.
No. The wrong answer.
0.4.
No. the wrong
0.4.
No.
It
0.24.
Sir, 0.24.
Yes, answer is 0.244 ampere. See, all these two bulbs are given in series connection. Clear? So let's understand this. So you can see that the circuit is look like this way. So first bulb, please turn off your mic. Those who have turned on his mic, please turn off. Creates the noise in the between the lecture. Okay. So here you will see that two bulbs, one is of 100 volt, 200 volt, connected in series with 100 watt bulb of 250 watt. These two bulbs are connected in series, and across them 250 watt supply is given. Yeah, you can see this again. Read this example: 100 watt, 200 watt bulb is connected in series with a 100 watt, 250 watt bulb across 250 watt supply. Clear? So both are connected in series. Across them 250 watt is given. So first you need to calculate current. How much current is flowing? So that is equal to what? Supply voltage divided by total circuit resistance. Clear? So here in your circuit we have two bulbs, but we not know what is the value of this resistance of these two bulbs. So first you calculate resistance of two bulbs, then you can find out the value of current flowing into the circuits, because ultimately value of current is I is what? Watt divided by resistance. So here first we calculate resistance of bulb 1. So as we know the equation of power, P is equal to V square by R. So from that we can make the equation of resistance, R is equal to V square by P. So first bulb has voltage 200 watt and power is 100 watt. So bulb 1 has resistance 400 ohm. Clear? Same way, second bulb, same wattage rating, but volt rating is 250. So same way you calculate resistance R2, V square by P2. V is 250 watt, P is 100 watt. So value of the second bulb resistance is 625 ohm. And both the bulbs are connected in series. It means both the resistance 400 and 625 ohm, that is connected in series. Clear? So what is the equivalent resistance of this circuit? R is equal to R1 plus R2. Clear? So total resistance of this circuit is 1025 ohm. And we need to find out what current flowing into this circuit. So current I is equal to what? Voltage. How much voltage applied across the circuit? 250 watt. So voltage V by R. So it means 250 divided by total resistance of this circuit. It is 1025 ohm. So it is 250 divided by 1025. Answer is 0.244 ampere. Clear all of you? All of you clear? Any doubt, sir?
No, sir.
Okay. So write down first this. First draw this figure. Okay. First draw this figure. Then calculate R1, R2. Then draw this equivalent circuit with resistance R1, R2. And then after calculate this current.
Sir, voltage across
Voltage across 152.5.
Yes, we calculate this, and in next slide we calculate this. First, write down all these things.
and second is 97.56.
Yes.
152.5 second.
Yes, I will explain you the second answer. Yes. First, you write down this first. Madana, thank you, Chana. First.
Yes, sir.
Okay, so I move for the next slide. Okay, what is the next thing? You calculate voltage across each lamp. Okay, so you can see here, we calculate resistance R1 and R2. Supply voltage is 250 volt, and current we already calculate 0.244. So it is very easy to find out voltage across each length. So here voltage across bulb 1, that is what, equal to current flowing into this bulb into resistance of this bulb. So V is equal to I into R1. So I is what? 0.244. Here 0.244 into R1. Resistance R1 is what? 400 ohm. So voltage across first bulb, that is 97.6 volt. બધા આવે છે આન્સર? ફર્સ્ટ બલ્બ નો વોલ્ટેજ 97.6 volt.
Yes, sir.
Yes,
Okay. Same way, second bulb has resistance how much? 625 ohm, and current is 0.244. So 0.244 multiply 625. How much?
152.5.
Yes, 152.5 volt. Clear, all of you?
Yes, sir.
બધાને આવે છે આન્સર? બધા લખી લેજો પ્લીઝ.
Yes, sir.
Yes, sir.
Okay, so can I move for the next example?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So next example, write down. Two bulbs rated 250 watt, 60 watt and 100 watt respectively are connected in series across 200 watt. Find the
Sir.
voltage across each bulb. Same type of question. Yes, any doubt? Anyone? Yes, please. कोई doubt છે?
Sir, both bulbs are rated 250 volt.
Yeah, they both are rated at 250 volt. Only wattage rating is different, 60 watt and 100 watt. Voltage
Okay.
rating is same, 250 watt. And
Okay.
both are connected in series. And across two bulbs, 200 volt supply is given. Yeah. So it is the same like a previous example. So it is very easy. First, all of you draw the circuit diagram. So it is very easy for you to understand this. First, draw the two bulbs in series. Write down the voltage rating and power rating. And then apply the 200 volt across them. Okay, what is the first step?
To find the resistance.
Calculate resistance.
Yes, very good. Find out the resistance of both the bulb, R1 and R2. What is the value? R1?
1041.6 and
Yes.
625.
625 and 1041.
Yes, R1 is 1041.66 ohm and R2 is 625 ohm. Yes, very good, very good. Then what is the voltage?
124.9 first.
Yes. Second?
75.
Yes, very good, very good. First is 125, second is 75. All of you get this answer?
Yes, sir. Yes.
All of you take your time, give the answer. We have 2 or 3 minutes. Then after I will stop this lecture. Is there any doubt in this lecture? Anyone in this 6 example? कोई कोई doubt है? Yes, anyone? So first, do the circuit diagram like this way. R1, R2, voltage rating, 200 watt supply is given. So here I calculate this example in a different way as compared to the previous example. So first we calculate resistance R1, R2. So that you already get R1 1041.66, R2 625 ohm, and then calculate the voltage across each bulb. So here you can see that bulbs are in series. So we know that current is same. Hence, the voltage across each bulb that we know that is directly proportional to its resistance. So we can say that V1 is directly proportional to R1 and V2 is directly proportional to R2. So I can write this ratio V1 by V2 is equal to R1 by R2. So here also same way I can write V1 divided by V1 plus V2, R1 divided by R1 plus R2. So the value of first voltage across the first bulb, that is equal to
125.
R1 divided by R1 plus R2 into V. So V is what? V1 plus V2. Here. So voltage across these two bulbs is how much? That is 200. That is given already. R1 we know 1041.6. R2 we know 625. So voltage across the first bulb V1 is 125. Okay. So this is another way I can calculate this example. You can also calculate the same way as we calculate the previous example. So as you know, V is equal to V1 plus V2. So you know V1, you know V. So directly we can calculate the V2. V2 is equal to V minus V1. V is 200, V1 is 125. So answer is 75 watt. Clear all of you? Is there any doubt?
No, sir.
No, sir.
Okay. So can I stop this lecture here?
Yes, sir.
Okay.
Yes, sir.
So
Yes, sir.
thank you for joining this lecture. If you have any doubt, you can message in this Microsoft team or you can also mail me at any time. Clear? So here I stop this recording and automatically this recording will be available.